Welcome to the DIY Honda Garage channel. DTC C1C02-15 indicates an issue specifically with the brake pedal stroke sensor signal circuit in the Honda CRV from 2017 to 2022. This code suggests a short circuit to the battery or an open circuit, which affects the electric brake booster system. The brake pedal stroke sensor plays a critical role in detecting the physical position of the brake pedal and transmitting this information to the vehicle's electronic control unit, ECU. It is usually located near the brake pedal assembly, making it essential for safe vehicle operations. If the signal is compromised, the vehicle may not engage the brakes properly, posing a significant safety risk. This troubleshooting guide will address diagnostic steps to identify and rectify the underlying issues causing this DTC. The brake pedal stroke sensor and the electric brake booster are the primary components affected by DTC C1C02-15. The electric brake booster is responsible for amplifying brake force, ensuring that when the driver depresses the brake pedal, the braking action is strong and responsive. In contrast, the brake pedal stroke sensor is crucial for detecting the position of the brake pedal and its pressure, transmitting this information to the vehicle's ECU. The sensor is typically positioned near the brake pedal assembly for precise measurement and response. A fault in the signal circuit indicates either a short to the battery or an open circuit, leading to potential failure in braking performance. Correct functioning of these components is vital for vehicle safety and proper operation. There are several possible causes for the DTC C1C02-15 error code. A shorted wire to battery may occur when the circuit connected to the brake pedal stroke sensor inadvertently connects with the battery voltage due to damaged insulation or wiring. An open circuit in the wire indicates a break or disconnection within the wiring that prevents the signal from reaching the ECU. A faulty brake pedal sensor itself may not correctly relay the pedal position, which results in the DTC being triggered. Each of these issues can stem from physical damage to wiring, wear and tear over time, or manufacturing defects, making thorough inspection crucial for accurate diagnosis and repair. Symptoms associated with DTC C1C02-15 may include the illumination of the brake warning light on the vehicle's dashboard, which serves as an indicator of potential braking issues. Drivers may also experience braking performance problems, where braking may feel sluggish or insufficient due to the sensor's failure to communicate pedal position effectively. Moreover, there may be instances of intermittent or no signal sent to the ECU, leading to further complications in brake system functionality. Such symptoms can create a critically unsafe driving experience, warranting immediate attention to ensure the electronic braking system operates reliably. The first troubleshooting step involves placing the vehicle into the on mode. This means the electrical systems are active without starting the engine. Next, using the Honda Diagnostic System, HDS, the technician should clear any stored DTCs. Clearing the DTCs is essential to reset the system and prepare for a thorough diagnostic review. After clearing, the technician should turn off the vehicle to lock mode, ensuring not to open or close the driver's door during this procedure, as it can interfere with the system's electronic settings. Waiting for at least 5 seconds allows the vehicle's system to fully reset before turning it back to on mode for a final check of DTCs. This step sets up a clean slate for observing any recurring issues. Upon confirming DTC C1C02-15 post-clearance, the next troubleshooting step involves checking for shorted wiring. The technician must ensure the vehicle is in off mode with the driver's door open as this prohibits the system from entering a standby state. After waiting for the necessary 3 minutes, the 12-volt battery must be carefully disconnected to ensure safety while working on the vehicle's electrical systems. Then, the technician needs to disconnect the electric brake booster 26P connector and the brake pedal stroke sensor 4P connector. This disconnection is necessary to enable accurate resistance measurements between specific test points in the next step, without any misleading readings from other connected components. In this step, the technician measures the resistance between two specific test points on the electric brake booster 26P connector, denoted as number 22 and number 24. This measurement helps identify whether there is a shorted wire in the circuit. As per the specified conditions, the vehicle should remain in off mode while the brake pedal stroke sensor 4P connector is disconnected to avoid inaccurate readings. The expected resistance should be 1 megaohm or higher. If the resistance indicates a lower value, it points to a short circuit in the wiring between the electric brake booster and brake pedal stroke sensor, necessitating repair. Accurate measurement is critical at this stage, as it determines the pathway forward in troubleshooting. The technician must again measure resistance, this time between test points on the electric brake booster 26P connector number 22 and connector number 11. The goal remains to assess the possibility of shorted wiring, as short circuits can lead to problematic signals being sent. The vehicle should still be in the off mode. As before, the brake pedal stroke sensor connector must remain disconnected during this test to ensure valid and accurate measurements. Achieving a reading of 1 megaohm or greater is vital. A lower figure indicates continuity issues in the wiring configuration, likely due to shorts connecting to the wrong power line. Proper assessment here directly impacts whether previous wiring needs repair or if further steps must be taken. Moving on to the 5th step in the troubleshooting process, the technician will measure resistance between the electric brake booster 26P connector number 22 and the brake pedal stroke sensor 4P female terminal number 1. The primary goal here is to assess the integrity of the PTS1 line. Conducting this test while the vehicle remains in the off mode with the brake pedal stroke sensor connector disconnected is crucial for avoiding interference. The required reading should be 1.0 ohm or less, indicating a closed circuit without brakes. If the resistance exceeds this value, it signals an open circuit in the wiring, requiring repair of the fault disconnected from the electrical signals that would impede normal sensor operations. In this step, the technician will again measure the resistance, but now the focus is on the PTS-VS line by testing between electric brake booster connector number 11 and brake pedal stroke sensor female terminal number 2. Consistency in conditions is key, as the vehicle remains off and the connectors disconnected as in previous steps. A reading of 1.0 ohm or less is essential for confirming that the wiring is intact and has no breaks. If a greater resistance value is detected, repair is required on the open line between the electric brake booster and the brake pedal stroke sensor, preventing effective communication between the components, crucial for proper ECU functioning. Finally, the last troubleshooting step involves measuring the resistance between the electric brake booster connector number 5 and brake pedal stroke sensor female terminal number 4. This measurement assesses the ground line integrity, PTS-GND line. Following the established procedures, a reading of 1.0 ohm or less indicates that the ground connection is consistent and intact. If the resistance exceeds this threshold, it suggests an open line, necessitating necessary repairs. Beyond just wiring, technicians should also check for any loose terminals or poor connections in the connectors. which can impact overall system performance. In cases where all connections are solid but issues persist, replacement of the electric brake booster may be warranted to restore full functionality to the braking system. After completing the necessary repairs based on the above troubleshooting steps, it's imperative to verify that all repairs have achieved the desired outcome. The technician should first recheck for any DTCs using the Honda Diagnostic System, HDS. Ideally, with effective repairs made, the DTC C1C02-15 should no longer be present. Following this, confirming that the vehicle operates normally under various driving conditions is crucial to establish that the issues have been fully resolved. If everything checks out and the vehicle is operating properly, the technician should clear any remaining codes in the system to finalize the process, ensuring an updated and accurate diagnostic history in the vehicle's records. Preventive maintenance plays an essential role in prolonging the life of the braking system and avoiding issues like DTC C1C02-15 in the Honda CRV. Regular inspections of the wiring and connectors for any signs of wear, damage, or corrosion can help detect issues before they escalate to fault codes. Additionally, monitoring the overall performance of the brake system regularly ensures that any anomalies are addressed promptly, preventing potentially dangerous situations. Scheduled service for brake components, including sensors and boosters, helps maintain optimal performance levels. Establishing a proactive approach significantly reduces the likelihood of abrupt DTCs and enhances the vehicle's safety profile. In conclusion, DTC C1C02-15 is a significant diagnostic trouble code indicating issues with the brake pedal stroke sensor signal circuit. Understanding this code is vital for diagnosing any related braking system problems in the Honda CRV. The troubleshooting process outlined provides detailed steps to effectively identify and remedy possible causes, mainly focusing on wiring conditions and sensor functionality. Identifying wiring issues promptly ensures the vehicle remains operational without risking safety. Finally, embracing preventive maintenance will not only aid in avoiding such codes in the future, but also enhance the reliability of the overall braking system, contributing positively to the driving experience. Please like and subscribe to the channel. See you next time!